Good to go? Okay, so we'll talk about the InnoDB recovery. So let me first start with a bunch of reasons which you can, why you can lose your data. That's obviously something like hardware failure. It also could be hardware misconfiguration, like you can have too much cache on your RAID, which intends to corrupt your data in file failure. It could be software misconfiguration, like starting two MySQL servers on the same data files, which just makes things really bad. It often could be some maintenance errors, like people we would see would copy only one IVD data file and then figure out, oh, how do we get data back from it? And the other sets of reasons could be bugs. There are obviously some bugs in MySQL and InnoDB, while Google tells us there are a few, there are still some. There is also a whole set of operation system and file system bugs which may affect you. File system corruption, for a reason, again, could cause the InnoDB corruption because InnoDB data typically lives in files which reside in this file system. Another set of data cases, which I think probably takes, we do most of our recovery jobs, applies to the user errors. That's when user accidentally drops tables or deletes the data or does run updates and then wants the data back. And which is kind of very related to that is a security breach when somebody also does that delete, update, or drop, but that is not your user but somebody else who just broke into the system or exploited the privileges. So now I would look at the two main types of the data loss, which you can characterize to corruption, and then typically it happens like InnoDB is unable to start or you get an errors while trying to access your data, and then some missing data when you can have rows deleted and table drops. Now, this doesn't exclude each other. You can have a combination of both factors, but you have to look at those separately as we go in the data recovery process. Now, the question is where we can get the data back, right? Again, like if you say, okay, well, here is the system, I had some data loss, and I'm trying to get some data back. Where can I look for it? Well, it's obviously the InnoDB table space. Data is there. Now, even if it's removed from the data original location, chances are it could be also stored in undo table space, right? When you delete the rows, they're first stored in undo table space, and then they are purged from that over some time. It could be very quickly, or it could be with certain delay, depending on how your system is loaded or configured. It could be in a free space on the hard drive, right? When you have dropped a file while you're using the InnoDB file table, it will be in a free space in the file system. InnoDB log files, again, when you insert the new data, it's stored in the InnoDB logs, right? And InnoDB logs are cycled through, so you don't get a lot of data there, but some of the most recent data can be still there. Insert buffer, and again, some of the latest inserts may be in insert buffer, but not yet in the database. And finally, I would mention the binary logs, which can have a lot of insert statements, and if you like, you can insert update statements. You can get the data from those binary logs, and full query logs or slow query logs with all queries if you use performance patches, all this works. Now, the best way for service for data for recovery, that's your backups if you have those, right? So if your backups are in a good order, then you can just forget everything else here. The funny thing, however, is I was surprised for our data recovery. How many companies, like enterprise companies, which I would honestly trust, would care very much about the backups have been using recovery services from us, right? I mean, and people often tend to have backups, but there are some chances where something didn't work. Some people have some running out of space. Another funny case, we had people had been using InnoDB backup tools, and then as the license expired, it stopped backing up the data, right? And they just didn't ever notice that. Interesting thing here is, so we mentioned a few sources of the data you can get there, and the next thing is that you can actually consolidate data from those data sources. If you really want to recover as much data as possible, it is very good to look at the multiple sources and try to consolidate data later on. For example, in many cases you would say, okay, do you have any backups? Yes, we have backup, but it's 3 months old, so it's unusable. Okay, let us get that backup. We'll take some data from that backup. If not, data is usable itself. The data properties often are, because we can learn about the data, and if you understand what kind of data you're trying to recover, that can help to filter out the data later on. Now it could be say, okay, we also have backups, so we also have binary logs, but the binary logs only span for last week because we purged them later on. Okay, well that's cool, so we have also data for the last 7 days. And then you can take the corrupted table space or tables of deleted data and recover some rows from it, and then consolidate that with backup which is 3 months old and with binary logs for the last 7 days. Well, and typically it'll get much closer to complete data than if you would only use one recovery technique. Now, another good question here is what to do if you discover if you lost your data. If InnoDB got corrupted or if somebody deleted the table, and I would say your first goal in this case is to stop further data damage, because we mentioned the data could be in so many places, and some of them are completely free. It could be both free in InnoDB table space or free inside the file system. So just stop it right there. It's best even to kill -9, -12. Don't let it do some internal processes, because it could kind of do version, and then you wouldn't see the data in undo table space. If you're planning to recover some data from free space and partition, it is very well good idea to stop any writes to that partition. Remount it read-only or unmount it at all. If you must use that server for something else, take a snapshot, right? Especially if you're using Unix, that's easier, right? You can just DD partition to file like on some network device, and you will be able to use that later on for all kind of recovery tricks. The thing here is, in many cases, you end up doing some trial and error approach, right? You run recovery, maybe let's say InnoDB recovery, and it didn't work quite well. You tend to repeat it again, and it is often much better start with original data rather than data you attempted to recover but somewhat failed. So let us look at a bunch of recovery processes now, what you can do, and I decided to describe 3 of them here. One of them was some sort of like simple InnoDB corruption. Then another problem is inconsistency between information in InnoDB data dictionary, FRM files, and IBD files, and then like various major corruptions or deleted data which requires the use of InnoDB recovery tool. So, looking at a simple corruption, right? What usually happens is InnoDB starts to crash with like page corruption errors in the error log, right? And you can see the error message here. It tells you that it's failed to read certain page number, and it will most likely tell you what the page checksums are different. I would say in 90% cases, this is the mismatch checksum is going to be the error. There are also some rare cases when you would have, instead of that, you will have like, oh, it's operation system with error. For example, you get your bad hard drive, and so that's the reason for you've been unable to read the page. But for us, that is the most important thing here. Now, what can be in this error message, and what is various helpful information is what kind of information is that? So in this case, InnoDB doesn't really tell us what that could be, right? It tells that could be undo log page, and undo log page is actually bad because if you have that's kind of system space which can get corrupted, or it could be corruption of some secondary index with certain ID number which is specified here, right? In some other cases, InnoDB can tell you more details like, oh, that page belongs to primary or index named XYZ from certain table, which can be very helpful to see how you can troubleshoot the data, and we'll look at that later. Now, where a corrupted page can belong, and this is kind of sort of in the order of sort of a preference, if you can say so, about corruption. The best thing to happen to you is what that corrupted page belongs to some secondary index. Because if it is a secondary index, well, you don't need that secondary index to reconstruct the data. You can simply do table, or you can simply dump the data with MySQL dump, drop the table and reload it, right? It doesn't look nice, especially if the table is huge, and it may cause an operation nightmare, but it doesn't cause any data loss connection. It also could be key leaf page, which then you can have to skip some data from this page. It could be kind of branch leaf. Well, I mean branch page, right? So the page somewhere in the middle of in this case, you may end up losing more data. And it also could be various stuff like undo table space and insert buffer or system dictionary table. And in this case, things are worse, right? Because chances are we'll have to dump and restore all the table space, or even using the InnoDB recovery tools to get to our data. So for simple InnoDB corruptions, we typically use these options InnoDB fast recovery, like some magic option which you do not change unless you're doing some recovery. And if you use it in production, you set it to 0, or you actually don't change it from default, right? I mean, probably you most likely don't have this option in your ICDF file. There is no need to specify it for normal operation. It has values besides 0, which is normal use. It has values from 1 to 6, which corresponds to ever increasing number of kind of operations InnoDB will stop doing in order to get data most recovery. Now, if you are planning to use InnoDB fast recovery in other mode than 0, then it is best to ensure no application besides you access the database, right? I do it this way by simply running skip networking and using some custom socket file, which I assume nobody will connect to MySQL to the box, right, from outside applications. And I will tell, besides this manual correction, InnoDB also has its own correction. If you have InnoDB recovery enabled, the InnoDB will prevent you from doing writes. Right, so and that's another reason, right? Because to stop the application from accessing table, because you may get some weird stuff going on there. It may be like you use mix of MySum and InnoDB tables, and now your application can write MySum tables, but all updates to InnoDB fail, and you don't really handle those. Right. Now, those recovery options, they start from basically saying, okay, try to work in corrupted pages, and then it goes through different stages, and at value 6, it tells, oh, don't even scan the logs, right? Values up to 4 give you a relatively consistent data. Yes, it may not completely insert, buffer, merge, or Persian, but at least data is not is in consistent states. Now, values more than 4, like values 5 and 6, they correspond to skipping undo stage. That means that some transactions which haven't been committed will be seen in the database, and skip redo stage, which corresponds in the opposite direction, like some modified transactions may not be reflected in table space. So if you can do your recovery for values 4 and below, that's much better. And InnoDB will start with 1, and you have to increase it gradually to get InnoDB start and down 4. That's fine. So we already mentioned the secondary key corruption is the best thing to happen to you if you are planning to lose your data. Right? You do just add a table, change the engine back to InnoDB, or select it to out file, MySQL dump, and then reload. That's simple. Now, if it's primary key corruption, then it's possible you will be simply able to dump your table again, simply use it in the force recovery 1. InnoDB may complain if page is corrupted, and it may skip certain rows from that table, and you will be good. But most likely, if page is corrupted, the InnoDB will run into some assertion failure or some crash, right, later on. So what we do here, if table has a primary key, is we can select the data by ranges, right? If you look at the primary key, that page probably corresponds to a certain range of values. And even more, the corrupted piece of data on that page corresponds to, for example, a rows with ID 5 and 6. In this case, we can do one range from, let's say, 1 to 4, right? And then another range from 7 to infinity, and dump all the data besides those 2 rows which are corrupted. Again, very simple.
So the goal is just to skip that?
Yes. So you just skip those two corrupted rows, and well, you're fine, right? And what to do, and we have like some little script to that, which we can go in basically ranges which try to dump basically do the binary search to locate those pieces and dump as much of data from table as possible. What is also interesting here is that MySQL most likely will crash many times when you're trying to dump data, because I mentioned one page is corrupted. Well, you can have several pages which got corrupted. So you have to have a patient, like sleep for MySQL to restart. Another thing that you may consider, if MySQL does crash recovery correctly, you may also want to reduce the InnoDB log file size. If you're planning on crashing your MySQL 1,000 times, then it's much faster to do so with small log files than large log files. And it's fine to resize them as long as corruption is mild. Now, if you don't have a primary key in the table, then you have the hidden primary key which you can't access directly. In this case, you can try and go and buy secondary key ranges, which will use internal primary keys then, which is less efficient but also possible. Now, what happens if that's undo table space insert buffer or log? Well, that's bad. I mean, because you may be able to dump your data, and it's possible it will be the data loss will be very minor, but you won't be able to restore the normal operation of the same table space. You'll have to dump all the data, recreate table space from scratch, and recover. Right. Now, as I mentioned, you do MySQL dump to dump the data, and it can take a lot of time. And I would mention with ModKit, there is also a tool for parallel dump and parallel restore, especially in the modern servers with a lot of cores and a lot of hard drives. That may be a faster way to dump your data and then load it back. You can use this technique to get it, obviously, previous one, right? You can both have corruption within the system area of the such tables when you try your best. What actually happens worse is give me a second. Yeah. The second one is when system tables got corrupted. The InnoDB, indeed, if you has a bunch of system tables which are not seen to the user, and most important of that are sys indexes and sys tables, which pretty much tell the page, okay, this is table A, right? And then other table says, okay, table A has so many indexes, and these are the root pages for those for those stuff, right? If those tables, that data is corrupted, then InnoDB will have no way for accessing the tables. So, right? So you wouldn't be able to dump any data from it. And in this case, again, right, you can dump the tables which can be dumped. Again, try to use multiple recovery techniques so you have more ways to consolidate the data, and then you use InnoDB tools to recover the rest. Now, FRM and InnoDB. So, the MySQL metadata is kind of a mess, right? In terms of with InnoDB, you would have a copy of metadata in FRM files and also in the sys table sys indexes, right? Which has very large overlap in between. And then besides that, there is IBD file, which has the data which should be structured, matching those metadata. And it is possible for all those three things run out of sync, right? You can, for some reason, have lose your FRM file, or have run FRM file, or it could be like an IBD file for some reason has different structure than your information in sys tables and FRM. So you'll have to kind of bring it in sync. Now, we'll look at the most important kind of types of inconsistency we can run into. So the first one is when you, for example, wanted to drop a table same as MySum, and you simply deleted IBD and FRM file, hoping that's okay. Well, that's okay. The problem now is when you try to create a table, it will give you some nice cryptic error message, and if you will go in the error log file, you will see what there is a table with its name already exists in the InnoDB data edition. So in order to create a table with the same name, you'll have to clean that table up. So what do we do? Okay, that's actually. So what we can do here is we can create a table in the same database, like B. Structure is not important. Then you copy this table FRM file to a FRM, that is the table which you dropped, and then you can do drop table. Okay. You would see in the error log a bunch of error messages complaining, oh my god, this table is already wrong, has wrong ID, but InnoDB will still drop the table from its data dictionary matching that table. So now you're clean. You may need to clean up some remainder. I've seen like when you try to create a table, for example, in this case, it tells you the error message, but it tells you error message only after it creates an IBD file. So it creates an IBD file, but it couldn't create anything in data dictionary, so it doesn't clean up things properly and stuff like that. Right. So in this case, you can have IBD file, maybe a FRM file left, remove them, and now you're clean. There is no references from table A in your data dictionary. Now, the other idea is, okay guys, what do we do to kind of connect IBD file, right? So let's say I have an IBD file which I want to get back to this installation, and I don't have any like original table. Now, if you want to create a table, you describe a table space for that table, right? The discard table space and import table space are kind of crap. I mean, they are, I think, half implemented feature because they really only work on the same server and they only work on the same kind of table. So you cannot really discard table space for table A and then import that to table B, right? It has to be the same table because when you discard table space, the information about their table space ID is kept in a data dictionary, right? And that causes issue. So in this case, we create the same table, we go to this ABD file and we copy it to MySQL data directory, and we try import table space. And of course, we get some nice and very explanatory error message. And again, we have to go to the log files, right? I mean, this is a funny thing with all these helpful InnoDB error messages. They are not sent back to the client. We've got to go to error logs to find them. And you would see here what it complains what AIBD is one table space ID, and actually their data dictionary contains a different one. Okay. So what you can do, well, simply hack the IBD file to modify its table space ID, right? And in the tables I looked at, typically it's on hex 25 and 29. That's like two positions where table space ID is stored. And I know if you change those, then it becomes reorganized and you can kind of connect the table and it works, right? So that's very easy. I also mentioned there is a good process with a lot more details written on the blog by Chris Callender. So you may want to visit that if you need that. Now, if you look at their InnoDB tools for recovery. So this is the tools for low-level data instructions from InnoDB. So now we throw away all this like data dictionary stuff, everything else. These tools do use InnoDB primitives for some parsing, but only like very low-level. This is GPL code that's written and maintained by Kirkona. And it is kind of has its edges, right? Because I mean, this is not a tool you run every day. And as those tools which, I mean, then you only have to do something so every so often, it's may lack automation. Now, the tool set contains multiple scripts, and then the three general stages are we kind of sort the data out of table space by index ID. And why we have this step is because besides running the tools, it allows us to visually examine the data. It's like, okay, well, like employees table, we can look at the pages corresponding to that and see what kind of data is there. Is our tool recovering this data which looks valid from our just looking at it or not? Which is very helpful. If you have just like one guy in table space and don't have no clue where different pages belong, that would be very hard to do. The other tool is to prepare definitions for the tool to parse the data from create table. Again, the tool is rather higgish in the sense that you'll have to recompile the tool to recover different types of tables. And then the third tool called a page parser is the tool which extracts the data from given ID and puts it in the like, comma separated or tab separated format. So how does the general recovery process looks? Well, first we split table space by index ID, right? Just sort of a large amount of small files. Then we create a table definitions, and that's a nice Perl script which can be used to create that from create table. Now, using that, we have to rebuild constraint parser because this is a little tool which compiles in all these like checks regarding data types, and it also you may want to edit the table definition more because sometimes you have more information about data. Like you can say, okay, there is a date column, which we can only see that it is a date from create table. But you know what all dates in this table have to be for last 3 years. And that helps identify the data from garbage In particular, if you want to run recovery process, for example, not just on their pages from this given index ID, but say, okay, well, maybe some data was already allocated to other table, right? But it wasn't overwritten completely. So to recover last bits of data, you may want to run a process on the whole data set. And in this case, it's very important to have as many constraints as possible to avoid the garbage. Right. So let me get back a bit. I think I probably missed explaining something here. So if you look at the page in the InnoDB, right, and how things are structured. So the InnoDB allocates data to the tables in extents, right? As long as the table is large enough, I think more than 30 pages, then it allocates data by 1 next. So if you delete some data, page gets freed, but it's still allocated kind of to the same table, right? What is also important here, when page is freed, it is kind of logical stuff, right? InnoDB doesn't override that page with zeros or anything like that. So it will still contain the data. Now what is interesting here is when InnoDB allocates the data or even inserts the data to other page, it doesn't, let's say, cleans up everything from it. So it is possible the page was allocated to another index, right? And the index ID in the page header was rewritten, but it still may contain some old data, right? So that's what I mean. If you are trying to recover some last bits of data, you may want to do that. Right. So after you do constraint parts, so you run extraction process. Typically, it's done for a given index ID files, or you may also want to run for whole table space if you want to get large piece of data. Sometimes you don't get enough data. Sometimes you get too much data. Well, that is a repetitive process, which you may want to do several runs to figure out. Now, in more details, data drops, right? The challenge here, as you've seen, it says, okay, find the index ID which corresponds to the primary key of the table you're trying to restore. How to do that? Well, if the rows are deleted, then it is easy, right? You can create a table in the DB table monitor, and you get like a whole bunch of stuff in the log files, which, among other things, will include the information about the index for given table. Right? So in this case, primary key is ID 0542, right? So in this case, you just go there and, as you can see, use 0254 as directories, which basically means all the pages which corresponds to that version, and run constraints first. You can also see -5. -5 is an option which tells use MySQL 5.0 format, because in InnoDB 4.1 had a redundant format which was a bit different from 5.0. Okay. You can even run it for each page, and we often do that because that helps us to control how many rows were recovered from each page. Right? You can say, okay, well, we ran for so many pages, and you know what? Some rows didn't get any, some pages didn't get any data recovered. Why is that? And we can then visually compare the data, right, and see it. Right, but again, it depends on how kind of deep you want to go with data recovery. In many cases, if you're recovering some, crap from a social networking website, and if you get it, 90%, well, it's fine, other people wouldn't notice, or you just can go away where they don't pay you anything anyway. But if you are trying to recover some financial data, well, you probably want to recover as much as possible, right? Even if it makes you to manually go through every single page. Drop table. Well, drop table can happen in two cases. Now, if you're using InnoDB file per table, well, that's very bad luck. Or good luck. I mean, it depends on where you're coming from. Because in this case, you'll have to go and pull up your favorite file system data recovery tool and get you undelete the file. And then if you undelete the file and it's intact, well, that's pretty good for you, right? Because we just discussed in the previous section, it's very easy to kind of mount this IDB file back to the data, right? Now, the problem here is if it's not InnoDB file per table, so the data is in a table space, well, we can't find the index from a data dictionary, right? Because the row from sysindex and systables was already deleted. So what we do in this case, well, we can simply run recovery process for systables and sysindexes tables, and there is a table definition for those tables is available on our InnoDB tools website, so we can get the data. That's one approach. The second approach is say, okay, we know some text. I don't know, some text, some ID, something long enough and rare enough so we can just run a grep for it in the data files, and then we can look at the page, look at the index ID, right, which would be here. We can, if you found some our needle in this given index ID, well, we know what that stuff corresponds to primary key, right, of this table, and that is another way to find the data. Now, in the new version, which is actually in CVS, you can also consider -u flag of page for constraints parser, and that flag tells us to recover only non-deleted rows, because by default we delete all rows which have delete flag set and which not. And if you are recovering from the drop table, you don't want rows which were deleted from this table before it was dropped, right? You just want the table as it was just before it was dropped. So that's that. Now, another interesting thing here is what you can also, in InnoDB, primary keys and secondary keys from a page structure, they are very close. And the tool allows you not only to recover primary keys, but also all secondary keys. The secondary keys, of course, doesn't have all data in there, most typically. But if you have like long covering indexes, for example, you may be able to recover some good deal of data from it. Right, so that's also helpful. And in this case, well, if you have like index AB, you can simply create table definitions which corresponds to AB and AD is the ID, the amount of primary key, and then run parsing for that. Now, yes, I'm also running out of time, but that's good. I'm almost running out of my slides too. So now, by advanced recovery, I mean, okay, now what happens if InnoDB file per table was used and you cannot undelete file, right? I mean, like I haven't, for example, found a good tool how to undelete files from XFS. And just say, hey, they say that's straight impossible from website. Maybe it is, but I don't know. Well, and if you have a trash file system, corrupted RAID, and everything, bunch of stuff like that, what you can do is, well, you can simply take the whole partition and parse it as an InnoDB data file. You'll have a lot of garbage out there, but anyway, like you can see, and only pages which match your checksums are considered the valid InnoDB pages. That's why I like it a lot, right? Because it's really very easy to find InnoDB tables in the garbage. If that would be my sum, well, like that's pretty much impossible because it's very hard to distinguish my sum rows by structure, right, from anything else. Like InnoDB, it's easy. The challenge here, what you may do is you may need to modify the tools so it doesn't look at 16K boundary, but it actually overlaps for increments 4 by 4 pages, 4K by 4K, right? Because there is no guarantee your InnoDB table space or individual IBD files they are 16K aligned, whereas typically the block files and file system is just 4K. There is another danger. You may lose some pages because a single 16K page may be stored in 2 different fragments of file system. if you have a RAID, right? You can have one per page in one location and in another. And in this case, without understanding file system metadata, you cannot ever connect those to two pieces of a page. So you can't find these pages, and you'll have to just skip them. Okay, so final notes. So we are in the end now. Now, the tools and costs in development, expect some bugs, like in its rapid ages. That means also use latest tree, which is the best luck. I mean, we haven't done the release, I think, for quite a while. Now, also, do not expect 100% recovery, because it's possible, especially in the active workload data systems. As soon as you delete some data or drop table, some of that stuff gets immediately overwritten to something else, right? And I mean, these tools, they wouldn't allow you to get any data as soon as it's overwritten on the disk. And backups. I mean, guys, backups are very, very important. Your replication is not your backup. RAID is not your backup. You know, just backup is your backup. And another thing with backup is, of course, you've got to monitor backups. I mean, you see so many cases when somebody set up backups and forgot about them, right? And not only monitor backups, but actually restore backups very often. And I have take some time. I know that's painful, but try to restore from backups, like monthly or something. And that not only helps for data recovery thing that I'm speaking here, but it also helps you to understand, for example, how much time it takes. We've seen a number of cases when people will say, okay, we're doing MySQL dump backups, and it's all going fine, right? And backups don't really time that just increase linearly with the data growth. But as soon as your indexes don't fit in memory with digitally, your recovery speed can just skyrocket exponentially. So people were taking backups, but they didn't figure out that it now takes a week to restore from those backups, right? And that's maybe a bad surprise. Okay, that's all for me. Any questions?
You mean restoring from dumps?
Yeah, from MySQL dump.
Well, it's using not that snapshot.
Yes, yeah. Well, this is fine. Well, this is just one of the examples, right? But I mean, it's good to try to restore from backup anyway. I mean, there are some surprises in other cases. Like I would say, with LVM backup, I remember people saying, okay, we have this backup, but then we change it to, let's say, our log directory of a symlink, which happened to be in our partition. And the backup continued to work, right? And from monitoring standpoint, it's all fine. There is a fresh data which is always increasing in size, and you cannot really catch there's any conformity. But if you try to restore from that because logs haven't been snapshotted anymore, you can't, right? I mean, and this all can sound of silly, but if you look at the many servers over many generations of DBAs, then people forget who set up what, and there's all kind of crap happening. Okay. Cool.